Okay, this is part 3, Unit 10b. As we continue some more discussion of geometry here. So in this one, we're trying to determine the acreage of a property. And so we're looking at this figure right here, 1033. We're not going to be using those numbers 250 and 1200. We're going to be replacing those, but we're going to use them to find the area in acres of the property. And in our case, this length right here is actually 300 feet. And for this example, this is going to be 1800 feet. And we want to know, it's on a mountainside, and we want to know what is the area of this lot in acres. And so we've got a length along the river. So I'll highlight that right here. We've got a length along the river. We've got a diagonal length that, maybe this diagonal length is a little bit easier to walk down the mountain. But we need, in order to find the area, we need this height right here. And maybe that height might not be as easy of a hike to get up to, and so we might use this right triangle here to come across this way and then come diagonally down to this end point of the property, and we're going to use the Pythagorean theorem to find the height. So if we're trying to find this, remember in the Pythagorean theorem, the longest side, which is 1800, is the hypotenuse. And that's the side that is what we call the C value. So in this case, we're going to have h squared plus 300 squared equals the longest side squared. So if I subtract 300 squared, I'll get h squared equals 1800 squared minus 300 squared. So I'm going to take the square root of both sides to get h as the square root of 1800 squared minus 300 squared. And if you throw that into calculator, you'll get something like 1774.8239, rounded out to 4 decimal places there. So that's the height. So then the area is going to be 1/2 the base times the height. In this case, 1/2 the base is the 300 up against the stream. The height is that 1774.8239, and that equals 266,223.59 square feet. And now we want this as acres. So this information will be given to you. You don't have to remember the acreage, but 1 acre is 43,560 square feet. And so to change our dimensions there to that's square feet, we're going to multiply that. We want to change it from square feet to acreage, multiply it by, so it's 1 acre for every 43,560 square feet. And I get roughly 6.11 acres. So 6.11 acres is the approximate size of that property on the mountain side. So it's on a hill, and usually on the hill side. It's not easy to find the height, and so you find some kind of diagonal value, which we did there. But that would be the square footage of the property in acres. So it's a pretty good size land. An acre, roughly the size of a football field. It's a really rough estimate, but just to give you an idea of the size of the acre. So it's about 6.11 football fields in size. Okay, now we're going to talk a little bit more about triangles. So we went from a right triangle, which is Pythagorean theorem, to similar triangles. So we say two triangles are similar if they have the same shape, but not necessarily the same size, meaning that one is scaled up or scaled down a version of the other. So if we're looking at triangles, in this case, similar triangles, all of our interior angles have to be exactly the same, but the lengths of the sides don't have to be the same. So what happens is you get angle in one triangle is equal to the angle in another triangle. So A equals A prime, B equals B prime, C equals C prime. And then we get these corresponding side lengths, that the side length of one triangle divided by the side length of another triangle, the corresponding sides are congruent to some other corresponding sides, and so forth. So in 62, we have two triangles that are congruent, and so I'll call this A, B, C. So this little one is going to be A prime, B prime, and C prime. So the opposite side, this is going to be A, so this little side is going to be little a prime. So that side, whoops, oh, didn't want to hit that. That was the very wrong button. So when we're looking at congruence, and that means that this angle is congruent to that angle, this angle is congruent to that. I'm not going to be able to fit three little squigglies in there, but those angles are congruent, so then it just again means that little a over a prime, that ratio is equal to little b over b prime, and that ratio is also equal to little c over c prime. So those ratios are the same. Now we're going to look at an example of where we'd use similar triangles. So some cities have policies that prevent property owners from constructing new houses and additions that cast shadows onto their neighbors' houses. The intent of these policies is to allow everyone equal access to the sun for powering solar energy devices if they so choose to have them. It wouldn't be very fair if you got a nice roof that faces the sun. You want to put some solar panels on there, but your neighbor's house is shading your house all day long or half the day or whatever the case may be. So here's the policy for one city in particular. So on the shortest day of the year, a house cannot cast a noontime shadow that reaches farther than the shadow that would be cast by a 12-foot fence from the property line. The numbers in here are going to be a little bit different than what we're given, although the fence is going to be 12 feet. So in essence, the sun is going to come down across this line right here. And what it's saying is when the sun's at its lowest point, so we call that the declination of the sun. The lowest point is usually, for us here in this area, December 20, 21st, 22nd, somewhere right in there, where it says its lowest point, and it's going to cast. And if you kind of have an imaginary line where it hits the peak of your roof, if you imagine that imaginary line going to your property line, this ordinance says if you were to have a 12-foot fence there on your property line, then if you continue along that line, the shadow can't cast any further than this arbitrary point right here, than what a 12-foot fence would cast. And so in our example, we have a 12-foot fence on the property line, cast a 30-foot shadow. So in this example, you've got 20 feet, but for our example, we are going 30 feet. So the sun would actually be at a lower declination because it's casting a longer shadow. And on the shortest day, in the north side of the house is set back 50 feet. So instead of 30 here, this is 50 for us. So this would actually be from house to the end would be the 30 plus 50 or 80 feet. So that's how we'd modify ours. So there's the geometry we have set up. We want to know what's the height of the triangle or the house that we can have in order to still be able to be within the parameters of the shadow that we can cast. So if you look in there, I'm just going to kind of draw some arbitrary triangle. So imagine that's the height of the house. Here's the all the way down from the property line to where we're casting the shadow. So this is the height. This is 80 feet from here to here. And then we've got our fence right here that's 12 feet. And then the house to the fence is 50. And then we cast a shadow of 30 out to this point. Okay, now we can assume that these are right triangles here. Going from the horizontal to the vertical on your house. And we want to find out this height. And what we can look at is we can say, well, notice that this little triangle right here, that little triangle is going to be similar to this big triangle right here. And they're similar by what's called the angle-angle postulate. But basically that little triangle is contained within the big triangle. So they share a right angle, and then they both share this angle right here. So that satisfies what's called the angle-angle postulate. So then what we can say is, if we use this information right here, we can say that the ratio h over, so h is going in the vertical direction, so h over 12, that is going to be congruent to, and then we got to use the longest side, so this is 30 plus 50, so that's 80 over, and in the smaller triangle we have 30. So those two ratios have to be the same. So now we can just solve for h here. I'm going to multiply both sides by 12. So I get h equals 80 times 12 divided by 30. And if you multiply that out, it's going to be 32 feet. So your height can reach a maximum height of 32 feet to still be within the ordinance, or this property ordinance that the city has given. But again, that's using similar triangles to be able to determine this information without having to break out all of the tape measures, or having to wait for that day to come, and then you can actually measure, and get a big old long stick and try and measure where it's at. You can use the math and do it beforehand, and then construct your home, trusting the math and knowing that if you're 32 feet or shorter, you're going to be totally fine within this ordinance. So that's a look at some applications of geometry, and that wraps up Unit 10B. If you have any questions, please don't hesitate to let me know, and I appreciate your time.